Okay, question 3 of our FRQs. So medical researchers surveyed a large group of men and women about taking medicine as prescribed. Their responses were never, sometimes, or always. The relative frequency is given below. The relative frequency, so the probabilities are given. Okay, one person from those surveyed will be selected at random. What is the probability that the person selected will be someone whose response is never and who is a woman? So the probability women, never, is 0.0636. So that answer, the probability of never and a woman, is 0.0636. It's given in the table. Probability part 3 of this. What is the probability the person selected will be someone whose response is never or who is a woman? Okay, let's drop backwards. And means to multiply. Unless you're given the table, then you simply take the number from there. And means to multiply, or simply read where the intersection is. Never and women is right there. Or means to add. So we're going to add never, this column, these two numbers, or is a woman with these three numbers. The only problem there, and it's not a problem, this is an overlap. So we're going to add this plus this plus this plus this. Okay? So the way I did it, and the way the book, most things show it, is you take the probability of women, which is 0.53, probability of never is 0.12, minus the overlap, what we just found with the and, okay, what we just found here. So you can add and subtract, or I could have just added these four numbers, still get the same answer. Okay, that answer is 0.5864. That answer is 0.5864. The next question, part 3. What is the probability that the person selected will be someone whose response is never, given that the person is a woman? Okay, so now we're doing a little bit more. So it's a conditional probability, the probability of never, given, vertical bar, a woman. So we're talking strictly about this row. Of that row, of which there's 0.53, how many of those women said never? That's 0.0636. So we're dividing. It is the overlap of this answer, okay, divided by the probability of being a woman. So it's 0.0636 divided by 0.5300. That answer is 0.12. So I take the probability of their overlap, no, never and a women, which is 0.0636, and divide it by the total probability of a woman in the survey, which was 0.53. And that answer is 0.12. Part B. For the people surveyed, are the events of being a person whose response is never and being a woman independent? Are those independent? Well, let's look. What's the probability a person says never? Well, that's 0.12. Well, what's the probability that we just found of never, given they're a woman? Well, that's also 0.12. So since we can show that 0.12 equals 0.12, then we can say, yes, they are independent. Sorry, I got a little crooked there. We could have also found the probability of a woman, which is 0.53, and then the probability of woman given that they said never, which would then be this number, 0.0636, divided by 0.12. And that also gives me 0.3, which we found back here. It's just working backwards. So those are independent events. Okay, part C. It says, assume in a large population the probability that a person will always take medicine as prescribed is 0.54. So that's our p-value. Our p is 0.54, which makes Q, okay, which makes Q 0.46 if we need it. If 5 people are selected at random from the population, okay, we have a fixed number of trials. We have a p-value, and we have a fixed number of trials. Oh my word, this must be binomial. It's binomial. What is the probability that at least 4 of the people selected will always take medicine as prescribed? Okay, so we can do one of two things. We can look at this. Whoops, wrong page. Sorry. Let me get the right page. We can say, okay, it's binomial, and we can use this formula. We're finding that x is greater than or equal to 4. So that means we'd have to use this with 5 and 4. Okay, 4, 1, and plus, because we're finding more than 1. Or we can simply use binomial CDF. But because it says at least 4 of the people selected will always take medicine as prescribed, okay, that means we're going to find the complement of this. At least 4 means the complement of 4 or more, which means 0, 1, 2, or 3. So the probability of being greater than or equal to 4 is the same as 1 minus the probability of x being less than or equal to 3. So that's 1 minus the binomial CDF of 5 trials, probability of 0.54, and an x of 3. And then that answer is 0.241. So about 24%. So if we were picked 5 people at random that 4 or 5 people would not, will always take their medicine, that's about 24%. Okay, that one took me a little bit longer than the others. That took a little bit longer than the others, but still we're less than 10 minutes a question. Again, they want you to spend about 13 minutes per question on this. Okay, that's probability, that's binomial.